Hello everyone, welcome back. This is the lecture 6 of CSES Dynamic Programming Series, and today we are diving into another interesting problem, and the problem name is bookshop. Okay, so grab your notebook, stay focused, and let's get started. Let me read the problem statement first. Okay, so you are in a bookshop which sells n different books. You know the price and pages of each book. Okay. You have decided that the total price of your purchases will be at most X. Okay. What is the maximum number of pages you can buy? And you can buy each book at most once. Okay. So this is the input given. Okay. So we have to output the maximum number of pages. Okay. So the constraints goes from n goes from till 1000 and x is 10 is to power 5. Yeah. Okay. So let me just copy this and paste it here. Okay. So this is n and this is x. Okay. So this is a prize money and this is the pages. Pages. This is price. Okay. So we can buy any book, any book. Okay. Yes, we can buy any book with the price of 4853 and get pages of and get pages correspondingly. Okay. If I buy this book, if I buy this book, okay, the number of pages I will get 12 and with the cost of 8. Okay. So we have to maximize the number of pages with a given x. Okay, so it means I can buy books uh, if my whole total money is less than or equal to x. If my total money is less than or equal to x. Okay, so I hope the problem statement is clear to everyone. Yeah, as we can read in this. Okay, so answer for this test case is 13. Okay, we can buy first and third book, first book and third book, and the prize money is 13. Oh, sorry, the number of pages is 13, and total price of this buying book is 9. Okay, which is under 10. So I hope the problem statement is clear to everyone. Now we will moving forward to our solution. Okay, so this is the basically knapsack problem. Uh, so let's solve it. First, let's understand the memoization solution. Then we go for tabulation. Then we go for space optimization. Okay. So this is, let's say this is a price array. Price uh, 3, 4, 5, 6, 7. Okay. And the number of pages is equals to pages is 8, 9, 7, 6, 5. Okay. Yes. And my x is equals to 15. Okay. So let's see how many options I have to choose the books. Okay. So this is the book 1, 2, 3, 4, 5. I have two options. Either I can select this book or either I cannot select this book. Okay. So if I not select this book, I will shift my index to index plus 1 and keep the remaining things. Okay, so this is the non-take part. If I not take, I will simply move to index plus 1 and remain the prices array, same pages array and dp. Okay, and this is my x. Okay, this is the non-take part. Okay, now if I take this element, if I take this book, okay, the number of pages I will get is 9. Okay, the price is equals to 3. Okay, so if my I can only buy this book if my x is greater than or equal to 3. If it is less than, then I will not be able to pick this book, right or wrong? Yes. Okay, so let me write this. If my x is greater than or prices of index, then I can take this element pages of index plus, and then I will move index plus 1. So now I can borrow this element. I have already borrowed this. Just a second. I have already borrowed this book, okay, with the price of 3. Now my x will reduce to 12 because 15 minus 3 is equals to 12. Yes, okay. So my uh, x will reduce to x minus prices of index, comma prices, pages, and dp. Okay, so this is my memoization solution. Okay, so at the end of the day, I have to take the minimum of not take and take. Okay, so just me write this. Return take, return minimum of take comma not take. Okay, so in the base case I will simply define if index is less than 0, then I will return 0. Okay, because let's see, if my index will reach till the end, there is nothing here, so I will simply return is equals to 0. Okay, so this is my base case. Let me show you the code for the memoization part, then we go for a tabulation. Okay, so where it is, yeah, bookshop. uh, I guess this is the memoization code. Yes, this is the memoization code. If index is less than 0, then I will simply return 0. If my answer is already computed in the states of dp of index and w, then I will return dp of index and w. Okay, so this is the non-take part. Okay, as we already discussed, and this is take part. If v of index is less than w, then I will take number of pages plus, then the w will reduce to v of index by v of index. Okay, this is the next call. Then I will store dp of index w is equals to max of take comma not take. Sorry guys, this is a take part. This is take. This is maximum. Yes, this is not a minimum. This is a maximum. Okay, we have to maximize the answer, not minimize the answer. Okay. Yes. So yes, this is my memoization code. Let's move to the tabulation. So for the tabulation part, we already know the states of dp, right? dp uh, dp of I comma w, okay, represents the represents the maximum number of pages till the ith index with the with the weight of w. Okay, so it represents the maximum number of pages, okay, till the ith index with the weight of w. Okay, it means I can choose an indexes such that the maximum will store in dp of I comma w. Okay, so now the states has been defined. We will write the transition for this. Transition is look something like this. I will run a two for loops, one for indexes and one for weight. Okay, one for indexes, okay, one for weight, okay, 0 till w. Okay, so in our memoization part, we see that first case is to not take. Okay, so let me write this in our tabulation. A dp of I comma j, is nothing but dp of I minus 1 comma w. Right or wrong? This is the non-take part. Okay. This is the non-take part. Okay. So yes. So for take part, we know I can take only element if my x is greater than of v of prices of indexes, right? So I will check in this. If my prices of I greater than or equal to x, then I can select, then I can take is equals to dp of I, dp of okay. So I can take pages of I plus dp of I comma v minus w minus v of index, basically prices of indexes. Okay, so this is nothing but the transition. For this I can add this in our answer, and in this we are going index plus 1. Okay, so but in this I can copy the previous states w minus prices of index. Okay, so now my dp of I comma j will become maximum of take comma not take. Okay, so this is my transition, and my final answer is stored in dp of n comma w. Okay, so I think this problem is clear to everyone. Okay, let me show you the tabulation code. Okay, it will be much easier. Tabulation code. Okay, so this is no, so this is the tabulation code. Okay, take the input. We will declare a dp vector of n plus 1 k plus 1. We can declare that because n is 1000 and k is 10 is to power 5. Okay, so 10 is to power 5 into 10 is to power 3. Okay, it will become 10 is to power 8, which is under the constraints. Okay, but it will give me a wrong answer, runtime error, because I am using over space, so we have to reduce it as well. Okay, so for I will run a two for loops. First loop will run from index 1 till n. Okay, second loop will run from 0 till k. For the non-take part, I will simply copy the previous states. For the take part, I will simply take the number of pages I will get. Okay, plus this. Okay, for the previous states. Then I will store the maximum of take comma not take, and my final answer is stored in dp of n comma k. Yes, that's it. This is the memoization part. This is the tabulation part. Now we will move forward to the space optimization. See, so for the space optimization part, if we see carefully, our dp of states depend upon the previous state. Like for the non-take part, it depends upon the previous states, dp of index minus 1. Okay, for the take part, it also depends upon index minus 1. It means it will take the previous states. Okay, so I will take the maximum of previous states and stored it in the current state. Okay, dp of index comma index w. Okay, so instead of 2D vector, we will create two vectors of previous and current. Okay, let me show you what I'm trying to say. This is a dp line. Okay, this is my current. Okay, this is my current. Sorry for this. uh, this is my current. Okay, this is my previous. Okay, if I'm standing here I have to assess these states, right? I have to assess these states. This uh, these states, to assess these states, it will automatically give me by the previous index. Okay, then I will simply now my previous will become current, and current will store the maximum of these indexes. Okay, so yeah, this is the whole optimization. Okay, so let me show you the code for the space optimization part. Instead of 2D vector, I will create a two vectors, previous and current, with the size of k plus 1. Okay, initializing with zeros. So where if dp of index minus 1, then I will give previous. Dp of index minus 1, I will give previous. Okay, now dp of index, it means this is current. Okay, I will store it in a current. Now my previous will become current, and I will return previous of k. Yes, that's it. We will discuss three approaches to this problem: memoization, tabulation, and space optimization. So thank you very much, guys. I will share a link of three problems, of three approaches to this problem in the description box. You can check this out. Okay, so thank you.